I'm expecting you to know this quadratic formula. So whenever you get a quadratic, you can find the two roots by using this formula. If the discriminant, that's the thing in the square root, is bigger than 0, then you're going to get two solutions. If it's equal to 0, then there will be one solution. And if the discriminant is less than 0, you're going to get no solution. So in this video, we're going to try and understand why that's the case. So let's look at this thing here. We want to find the two roots. So we would put 0 into the y. So the normal routine would be this. Put 0 into the y, because at the two roots, the y value will be 0. So put 0 into the y and solve this equation. Now we could use this, but I just want to complete the square so that you can see what's going on. We're trying to understand why the discriminant is so important. Okay, so to find the solutions here, we would complete the square. I'm expecting you to be able to complete the square. So it's going to be half of this. So that would be minus 4. And then you take away minus 4 squared. So that would be take away 16. And then you carry this 7 down. I'm expecting you to be able to do this. So now single number, merge them together. That would be 9. So now you want to make x a subject. So you would add 9 to both sides. You would square root both sides. Then you would get two solutions, the positive version and the negative version, and then you would add 4. So that's how you make x a subject. Now what this is going on, what's going on here is that you start at positive 4. So right here is negative. Right here is 4, and then if you add 3. Because square root of 9 is 3, it would take you, if you stand at 4 and then move to the right by 3, then it would take you to one root, and then if you take away 3, it would take you to the other root. So you can see that when you square root a positive number, you're going to get positive 3 and negative 3. That's why you stand at 4. And then you add 3, it will take you to the right root. And then if you take away 3, it will take you to the left root. Now let's look at this one here. Now let's look at that one. Hang on. So this one here, bear with me, you will understand why this discriminant is the way it is. So let's complete the square here. We want to find this point here. What's so special about this point? Well, at this point, the y value will be 0. So you would put 0 into the y and then solve this. I'm just going to complete the square in one go. Always half of that, so that would be minus 4. Take away 16, and then you add 16. So these two will cancel each other out, equals 0. Let me just put 0 in there. Take away or plus 0. I'm going to say minus 0. It doesn't matter. I'm just putting this in here to illustrate something to you. So now make x a subject. You would add 0 to both sides. That would then give you this. And then you would square root both sides. Two versions. And then that would then give you x minus 4. And then you would add 4. So you would add 4. So x equals this. Now, this is when the discriminant is equal to 0. So you've got to square root 0. So what that means is you stand at 4, and then you move to the right by 0, and then you move to the left by 0. Hence the reason why there's only one solution, because you stand at 4, and then you move to the right by 0. That's why the discriminant here, when it equals 0, you square root 0, means you move to the right by 0, and then you move to the left by 0. Now let's try and understand why this is the case. So hang on. We want to find out when it crosses the x-axis. Here, because of the diagram, you can see that it doesn't cross over, but let's pretend we didn't know that. Let's pretend we assumed it's like this. Let's assume the graph looks like this. And we want to find out these 2 points. What's so special about these 2 points? At those 2 points, the y will be 0. So you would put 0 into the y. It doesn't look like this. It looks like this. But let's just pretend we didn't know that. So let's just complete the square on this. So completing the square, half of that. So that will be x minus 4 squared, take away 16, and then add 17. So negative 16 plus 17, that would be positive 1. That would be positive 1. So now, make x a subject. You would take away 1 from both sides, take away 1, and then you would square root both sides, get two versions, positive version and the negative version, and then you would add 4. So what that means equals x. So what that means here is, it's saying the solutions would be 4 and then plus square root of a negative number. You can't square root a negative number. What's the square root of negative 9? You can't do it. You can't, as far as you're concerned, you can't square root a negative number. So whenever you encounter this discriminant being less than 0, you're going to be asked to square root a negative number, and that can't be done as far as you're concerned. So here, hang on, let me explain something. Hang on. So truly the graph looks like this, but when we started the problem we said, oh, let's try and find the two solutions. So we would put 0 into the y, but the graph will never equal 0. So the minute you put 0 into the y, you're forcing the equation to be 0. And the equation here, the graph here will never be 0, and you're forcing it to be 0. So when you come to solve it, it will give you an absurd scenario where you have to square root a negative, because the graph truly looks like this. So you can't really put 0, you can't really force the y to be 0. The minute you force it to be 0, then it's going to ask you to square root a negative number. So it's going to be an absurd scenario where you have to square root a negative number. So whenever you encounter this thing being negative, it means that you have to you're being asked to square root a negative number, which is an absurd scenario for you. So that's why when this is less than 0, you're not going to, you can conclude that you have to go back in here and say, oh, the graph will never cross over the x-axis. Okay.